Let's get started on 4.7. This is the fun one. We are solving problems here. Let's look at this first one. Some engineering students constructed a potato cannon, fun, on the roof of a building. The height above the ground, h meters, of the potato cannon, t seconds after it is shot from the cannon, is modeled by that equation right there. What can we figure out just by looking at the equation? Not at the graph yet, but just at the equation. Well, first of all, we do know the 10. That's your y-intercept. That would be the starting point. The starting point is when time is 0. Well, that's going to mean that's how high it had to have been above the ground. In other words, the roof is 10 meters high. We can also see that right from the graph. That's your y-intercept. Now looking at the graph, what's the maximum height? Well, maximum height's going to be right there at the vertex, which is 30 meters high. And at what time does that occur? Well, that's going to occur at 2 seconds. Now the question says, though, is how long has it been in the air for? So that would be the full time that it's here, and that's going to end up being 4.5 seconds in the air. Let's try out this next one. Starts getting a little bit trickier here. Find two integers that have a sum of 24 and the greatest possible product. As soon as you see that greatest possible product, that's meaning that we got a max product. Now write that down, that it's a max product, because that's going to be important. What this is going to mean for every one of the questions is that we're going to be using a product equation to find the vertex. Okay, so remember there's two different ways of finding the vertex. We could either complete the square, or we could find the two x-intercepts and go halfway in between. So let's check it out. We always want to define variables. We're going to use x and y just for the fun of it. So let's let x equal the first number, and let's let y equal the second number. Always make sure that you define your variables. It says we've got a sum of 24. Okay, well, that means a sum, we're adding them together. X plus y, that's going to equal 24. And we've got the greatest possible product, max product. That means we need a product equation, which is going to be x times y. But we have to have a product equation with only one variable. I've got two of them. I got x and y. We've got to somehow substitute one equation into the other. So with the first equation, isolate either the x and y, doesn't matter which one. Let's just pick y for the fun of it. So y equals 24 minus x. Let's substitute that in for the other y. Alright then, p is equal to x multiplied by the 24 minus x. We now have a quadratic in factored form. Option number 1, expand this and complete the square. Option number 2, take the two factors and look halfway in between them. Decide which of the two methods is going to be easiest. We've already got it in factored form. Hey, let's look at the two factors. X equals 0 and 24 minus x equals 0. So x equals 24. There's our two x-intercepts. Our vertex is going to be halfway in between. 0 plus 24 divided by 2, 12. There's the number that we're going to use. That's the x-coordinate of the vertex. So we know the one number. Let's figure out what the other number is. Going back into the other equation, y is equal to 24 minus the 12 that we just found for x. Y is also equal to 12. And what's the maximum product? Product is equal to the 12 times the 12, which gives us 144. Now there's a process to follow for each one of these. And let's go through, as your book shows, kind of a nice process to go through. Using this example, a person has 100 meters of fencing to enclose a rectangular garden. Sometimes these gardens are going to only have 3 sides instead of 4 because it might be a wall on one side. Sketch the diagram first. So draw it. Label with your variables. That's a way of describing and defining your variables. Instead of using let statements, you can put it onto the diagram. If we're looking for a largest possible garden, that's meaning max area. If you're looking for max area, we need an area equation with one variable to find the vertex. So we use our area formula, length times width, but I've got 2 variables there, so I've got to use the other information on perimeter to fill it in. Using the perimeter equation, 2L plus 2W, we then solve for W, or L, it doesn't matter which one. We've got 50 minus L. We're going to substitute that now straight in for the W in the other equation. By substituting in the W, we then can rewrite it if you so choose. You don't need to. You could have gone straight from there. But because this one is in factored form, we could look at the 2 factors, 0 and 50. And we know that the vertex is going to be halfway in between. So adding the 0 to 50 divided by 2, we know that the length is going to be 25. Just take your 25, substitute it back into the formula there, and we can get our A, our maximum area, which gives us 625 meters squared. We could substitute the 25 in to solve for the W. And oh, look at that, we also come up with 25. That's usually going to be the case. Maximum areas go with the squares. Alright, let's try this one out ourselves. 2 numbers have a difference of 18. Does their product have a max or min? Ooh, we have to decide here. The way we're going to decide is we're going to do some of the math and we're going to look at the equation. Remember, a max or a min is determined by the A value. That'll tell us, hey, is it opening up or is it opening down? Let's look at it. First thing got to decide to do, got to define your variables. So let's use X and Y. So let's use Y to be the first number. And I'm actually going to choose the first number to be the larger of the 2 numbers. And then I'm going to let X be the second number, the smaller number. So how I'm going to write that then? If the 2 numbers have a difference of 18, that means the larger number minus the smaller number equals 18. Now I'm looking at their product. So I need a product equation to find the vertex on. So product is equal to X times Y. we need to either solve for the y or solve for the x. And it doesn't matter which one you solve for, I'm just going to isolate the y just because that's what we always seem to be doing. And it's a little bit easier with the negative here. 18 plus x. Same as each time, substitute the y in for the y in the other equation. So we've now got p equals x times 18 plus x. Okay, so is that going to be a max or min? If we expand that, we get p equals 18x plus x squared, or p equals x squared plus 18x. Looking at that, we notice that the a value in front is a positive 1. So that means it's opening up. We're going to have a minimum. Let's find our vertex. Either complete the square or use the factored form. Oh, this one is easier with the factored form. We're just going to take it and say we've got 0 as our first x-intercept. We've also got as our second x-intercept, we've got negative 18. Halfway in between, that's the number we're looking for. So x equals 0 plus negative 18 over 2. Our x value of the vertex is negative 9. And that's going to be the first answer. That's going to be answer for x. The value of x is negative 9. We now need to go and find the value of y, the second or the larger number. So y equals 18 plus that negative 9 we just found, which is 18 minus 9. Oh, that's 9. So the larger number is positive 9. The smaller number is negative 9. And just for the fun of it, what is the value of the product, which is the minimum product possible? That's going to be 9 times the negative 9. So product is equal to the 9 times the negative 9, which is negative 81. And we're going to finish off with this more difficult type of a question. And I will do a bunch more of these in class to show you how to do these ones efficiently. So every week a takeout restaurant sells approximately 2,000 chicken wraps for $1.50. Yum. Through market research, the restaurant manager determines that every 10-cent increase in price, she's going to sell 100 fewer wraps. Well, is that a good thing? Is that a bad thing? We got to do the math and find out. That's the importance of this type of a question. What is the price of a wrap that will maximize revenue? That's really all she cares about. What's going to give her the most money? Not, can I sell the most wraps? Not necessarily. It all comes down to what will give me the most money. So we need to know what revenue is made up of. Revenue is made up of the cost, the price of what you're selling, multiplied by how many you sell. So price times numbers sold. And we're trying to maximize revenue. That means I need a revenue equation with only one variable to find the vertex. Well, let's figure out how we're going to find the price. First of all, the price is $1.50. But that changes because you're increasing the price by 10 cents. You could increase it once, 10 cents, or you could increase it twice, 20 cents, or 3 times, 30 cents. So we're going to be increasing plus the price by 0.1 times the number of increases. Oh, I just introduced a variable. So let's put let n equal the number of increases. You got to define your variable. Now let's look at the numbers sold. The number sold is going to be made up of original, 2,000. But this time it's going down. You're selling fewer wraps. So every time you have an increase, it goes down by 100 for every increase that you made. Both of those two parts follow a little bit of a cookie cutter. Original, the original amount, plus or minus, plus if it's increase, minus if it's decrease, the change, whatever change they give in the question, multiplied by the n, the number of increases or decreases. Let's box that in because that's kind of your cookie cutter right there. Let's go back to that revenue equation in red there. Let's put it in. So our R, revenue, is made up of your price, which we now know is in blue there. 1.50 plus 0.1n multiplied by that purple stuff, the 2,000 minus 100n. So again, we could expand this and we could complete the square. Find the vertex. Or we could say, hey, it's in factored form. Why don't we take each of the two x-intercepts and find what's in between? The vertex is in between the two x-intercepts. So the first x-intercept on the blue is going to be n is equal to, well, let's actually write it all out. 1.50 plus 0.1 n equals 0. That means 0.1 n equals negative 1.50 divided by 0.1. N is equal to negative 15. And in the purple, we've got 2,000, oop, missed a 0, minus 100n equals 0. Subtract over the 2,000. Negative 100n is equal to negative 2,000. Divide by the negative 100. N is equal to 20. Finding out our x-coordinate of the vertex. Negative 15 plus 20 divided by 2. N is equal to 2.5. But wait a minute. Nowhere does it say that we're allowed to do 0.5 of an increase. So we have to make an assumption here that we're only able to increase by whole numbers. So we're going to say either 2 increases or 3 increases. Because it's a symmetrical graph and they're both the same distance from 2.5, either 2 increases or 3 increases are going to give us the same revenue. Now that we have the number of increases, we can either take 2 or 3 in this case. Or if we were allowed half increases, we could say 2.5 increases. Let's work with 2. So let's say n is equal to 2. 2 increases. Let's find our price. Our price is equal to 1.50 plus 0.1 times 2. Work that through, and we're going to get $1.70. So the best price to sell at is $1.70. And now we need to know the number sold. So we're going to take it, number sold, and that's going to be 2,000 minus 100, and put your n value in there, 2. Work that through, and that's going to be, we're now going to sell 1,800 of them. If you would use 3, you would have said it's $1.80, and you'd sell 1,700. As the owner, you're going to have to make the decision, do you want to go 2 increases or 3 increases? Revenue is equal to the two numbers multiplied together. The price, $1.70, multiplied by the number sold, 1,800, which gives us $3,060. I know that these get tricky. I'm going to go over a few more of them in class, show you that again, go through the process again, make sure you see how to go through each one of them and set up the problem. Setting up the problem, that's the hardest part of all. That's why the discuss the ideas here help you with thinking through that process of setting them up. All right, good luck with that, and we'll see you in class.